Hey everyone, just wanted to give a recap of the LangChain agent conference I went to a couple weeks ago. It was a really good conference and just wanted to share some of the things I learned. Here's some links, a YouTube playlist of the conference talks, all of the transcripts of each talk, and also an AI summary of every talk. And in this presentation, I'm just going to try to summarize some of the things I learned. There's probably 16 hours of content I'm trying to summarize in less than an hour, so I'm not going to get through everything. But day one, it was a hands-on workshop. A couple of people from LangChain went through how to create an ambient agent from scratch, and they gave a pretty detailed demo through these Jupyter notebooks on how to build an agent piece by piece. They actually shared Python notebooks as well as TypeScript notebooks. This is actually the first time I've seen TypeScript Jupyter notebooks, and I forgot that you can have actually any language in Jupyter, which was pretty cool. And just to define the term ambient agent, normally um, the interface to agents now is a chat interface, kind of like ChatGPT, but ambient agents work differently. You can think of them as like background running cron jobs that listen to an event stream and act on it accordingly. Um, and they can take action based on those events. So this is a diagram of what we built together. The agent was built in LangGraph. It surfaces interrupts, to solicit human feedback. There's this open source project called Agent Inbox that LangChain has built that is also pretty cool to, receive those interrupts and also send messages back to the agent. You can approve the emails, and then this will actually send an email out. And then they also talk through memory. And I think the most fascinating thing that I learned during this workshop was the human in the loop piece. So just to go into detail a little bit, uh, the agent that we built was an email assistant connected to someone's Gmail. When an email comes in, the email is sent to the agent, and three things can happen. The email could be ignored. If it's spam, uh, the assistant could decide to respond to the email, which will generate a draft of the email to respond with. Um, and maybe there's some sort of question that the agent needs clarification on, in which case this will ask the human for human feedback. So at these green nodes here, this is where the human is in the loop to give feedback on either a question that the LLM is asking or maybe some feedback on the draft of the email that the agent wrote. And once you've given the agent feedback, the agent can take that feedback, generate a new email. A tool call will be made to call the Gmail API to send the email, and the email will actually be sent. So this is kind of a cool diagram that demonstrates how human in the loop could work in a production system with agents. And yeah, I just wanted to demo this briefly. Agent Inbox is a open source project that um, LangChain has written to handle these human in the loop feedbacks. So how it works is there's a hosted version as well as a locally running version. I'm just going to show the hosted version here. So how it works is you can set up an inbox by putting in your graph ID. So this has to be a LangGraph agent. You grab your LangGraph deployment URL. And I'm just using the LangGraph Studio desktop application. I think it's deprecated now, but it still works. So this is the email assistant HITL that is part of the Agents from Scratch repo that I linked earlier. So if I have this assistant, I'm going to create a new thread here. And I'm just going to pass in some email input here. So this is an example email. Imagine like this is an actual email that was received by a user, and this is now being sent to the email assistant for triage and possible draft generation. So let's try this. Okay, so we threw an interrupt here. Let me just refresh this left-hand side. So it looks like we have something now. The LLM raised a question to me. It says, "Hi Lance, Alex is asking whether the auth refresh this endpoint was written intentionally left out of the API documentation. Can you clarify if the endpoint should be included in the documentation or if the omission was intentional?" And I'm just going to say intentional. I'm going to send this response back. It's going back to the LLM. And now we have another interrupt thrown. This is the write email interrupt. So if I go back to this diagram, the first one was this first node. The second one that I'm looking at is the second node here. And now it generated this draft for me to respond to this user. And I'm just going to accept this. And now if I go back here, what's kind of cool on the right side, you can kind of see that the LangGraph agent just continued running. So during the interrupt, the agent was waiting for a message to be sent back. And once it got that message, it actually just continued running, which is really cool. So going back to this. So yeah, agent inbox, it only works with LangGraph, deployments. Could be local, could be hosted on their platform. You can also run agent inbox locally, but actually with the hosted version, you can test these locally running LangGraph agents as well. And the agent inbox gives you a pretty cool way to edit, approve, ignore, or provide feedback on actions that are taken by a LangGraph agent. And all you have to do is pass in the name that's from the langgraph.json file and also pass in the graph URL. And it's really easy to use. This was a slide that showed kind of a flow diagram for different agents and the actions that they can take. And I think one thing I appreciated from this was, even though this was a simple email assistant, it does actually take thought at each step of the user journey. What type of feedback is appropriate for that step, and actually coding that in your agent. So, for example, 3 actions could be taken after an email is triaged, right? If it decides to respond, it can respond one of 3 ways. It could raise a question, which we saw. It could write an email, which we saw, and it can also schedule a meeting, which we didn't see yet. But for each of these, the actions are different. So for example, if the agent raises a question and the human feedback is either I can ignore the question, which I don't do anything, in which case the agent will just keep waiting and nothing will happen. I could respond. So I could give the agent an answer to the question. I would answer the message, and I would follow this blue line back around. The LLM node would be called again, and the agent would reason over the previous messages and the history and decide, okay, do I need to raise another question, or now do I have enough to write an email, or now should I schedule a meeting? For the write email node, you can see that the actions are more, there's 4 actions you can ignore. So ignore the tool call, and then actually, I kind of misspoke earlier. This would actually just stop the agent from processing. So nothing would happen after this. You could respond by giving the agent feedback on how to respond to the email. So that's what we did in the earlier flow. So the agent would take this feedback message, generate a new draft, and probably present this email back to the user in this node, the write email node. I could accept the tool call, in which case the draft that was sent to me would just be passed to the send email tool. That tool would be invoked, and then the agent would finish processing. Or the last step is edit. So this one was a little bit more complicated, but I can edit the tool call directly, where maybe I want to directly edit the email that was written, add a couple sentences, or remove some. Here, they kind of talked about how one important aspect of this is actually editing the tool arguments directly, where if you do not do this, you'll have a mismatch in the edited tool message and the tool message that was passed in earlier. And so, I think the agent could get confused on which one is the actual message. So editing the tool arguments with the edits that you made is kind of the safe way to go. And once you've edited that, you can invoke the send email tool and then also be done. So yeah, I imagine designing agents in this type of systematic way, thinking through what are the types of human feedback I'd want to, you know, get from the user is, super important. And, also laying it out in this diagram is really, really helpful. I also, learned about the command feature. So the command feature is what's used to go to different nodes, and it was used largely in this ambient agent that we were making. So what happens is when an interrupt is thrown, um, a typical LangGraph agent, you might have just various like deterministic workflows. Like this is the workflow A or workflow B that I'm going through. What command allows you to do is actually specify which node in the execution graph you want your agent to go to next, depending on what happens. So, specifically, it handles two things. You can control and modify the state at the end of that node, and you can also specify which node to go to next, which is really powerful. Some takeaways from this workshop. I was reminded that tool calling is just structured output. I think I sometimes can forget that, when we talk about tool calling or function calling, as it used to be called, what we're doing is asking the LLM to generate structured output, some specific keys and arguments that are passed to a tool, and then that tool, that external function is called with those arguments. So an LLM's ability to do tool calling really is just, a subset of its ability to do structured output. A command, this line was from the LangChain docs. It's a special type that when returned from a node specifies not only the update to the state, which is, the usual thing that happens at the end of a node, but also which node to go to next. This allows nodes to more directly control which nodes are executed after the fact. So, I think it's a nice way to handle control flow in LangGraph agents, and I believe this is what is used in agent handoff, that feature in LangGraph. I think also building human in the loop interfaces does require tight integration between the front end and the back end of an agent. So in this example, the back end was in LangGraph, where you could define the different user workflows, coding all the different options for raising questions, writing emails, scheduling meetings. But this also has to be tightly integrated with the front end, where depending on what type of feedback you need, you actually need to present those, user input boxes to the user. And that should change depending on what step and what state you are in the actual agent. And yeah, I think complexity will quickly grow, right? Even for the simple email assistant, you could see how many different branches there were already. All right, just wanted to go to day 2 now. So day 2 was a series of talks. I'm not going to go through every talk, but so let's go through this. The first talk was by Harrison Chase. He used this term agent engineer that I don't think I've ever heard before. I've heard of AI engineer, which is kind of like a combination of software engineer with data scientist, a software engineer that is familiar with AI, building AI applications on top of foundation models like LLMs. Agent engineer, I think, is like a subset of AI engineers who they're not just building, applications that use LLMs, they're building agent-like applications. And he kind of talked about, okay, to do this effectively, you need skill sets like prompting, actually software engineering skills. You need product taste. You need to know some machine learning. And yeah, I generally agree with his take that this is now a skill set that is important to build robust agents. And his talk was a series of different beliefs. So I'll just go through some of them. His first belief: agents will rely on many different models. He showed this cool visual that shows a model's ELO score on the y-axis and the price per token on the x-axis. And each line represents a snapshot in time. And you can see that as time has progressed, right, we've gone from December to March to April to July 2024 and the August 2024 frontier. The models have gotten cheaper and better over time, and I expect this to continue to happen, maybe not at the same rate. And yeah, this is applied to both open source and closed source models. This is another similar chart that I've seen shared. The LMSys ELO arena score, and also the price per token. And notably, Google's models are actually are some of the best at every price per token, starting with Gemini 2.5 Pro and then down to Gemini 2.0 Flash. His third belief is building agents is a team sport. And yeah, I generally agree with this too, where to do this effectively, you not only need people who are familiar with how to build AI agents, right? You need knowledge about AI, you need knowledge about maybe a particular agent framework, you need to know generally how prompting language models works. You need some knowledge on how to evaluate the agents effectively, both offline and online. But you also need knowledge about the domain. What domain are you building this agent in? And that person, often does not exist in the same person who has the same skill set as all of this agent development. So I do think it is, at least for now, team sport. His belief for AI observability is different. He talked about how to do AI observability right, you typically need to surface large, unstructured, often multimodal payloads alongside your traces. So, I've also experienced this where, to effectively troubleshoot agents, you need to see, for example, the retrieved documents alongside of your RAG agent. Or if your agent is multimodal, maybe it's handling images, you do need to display those images, whether it was an input from the user or generated by the model. And so, AI observability tools like Langsmith are trying to address this market. His belief 5 was everyone will be an agent builder. And yeah, I think that this is true. At least we're moving toward this where, it's becoming easier and easier to build applications. I mean, this applies to just software in general, right? Vibe coding is now a thing. You can build, pretty useful applications just using these coding agents. And I think this also applies to agents themselves, where, LangChain themselves, they give and provide a bunch of different libraries to build agents. I think this is sorted by weekly downloads. So their MCP adapters library connects LangGraph agents to MCP. The supervisor Pi library allows you to build multi-agent systems using the supervisor sub-agent architecture. So yeah, all of these are kind of building blocks that you can use to build agents, at least in the LangChain LangGraph system. And then, so yeah, that's the LangGraph pre-builts. And then for citizen developers, they demoed this platform called Open Agent Platform, where it works with all LangGraph agents, LangGraph agents that are deployed in their platform. What this will allow you to do is for non-coders or citizen developers, they can call those agents, and they can also maybe build multi-agents with those LangGraph agents. So I haven't had a chance to play around with this yet, but it looks like an interesting tool, at least if you're in the LangChain ecosystem. Now I'll go into just different talks that were done. One of them was Harrison interviewing the head of AI at Repllit. He talked about Repllit Agent v2 and just some highlights of it. Repllit Agent v2 is much more autonomous. He was saying it can work 10 to 15 minutes by itself. And one of their metrics that they're tracking is how many Repllit users go in to edit code that the agent generates. And in V1, 1 out of 4, or 25% of users edited the code. In V2, that's down to 10%. And one of their stated goals is for users to not need to edit code at all. So they want to see this go to 0, which I found kind of interesting. And yeah, I had a chance to play around with Repllit Agent V2 while I was at the conference, and it is really good. I was surprised by its ability to just generate this full-fledged application that had a Postgres backend. But yeah, back to some of the things he brought up. He stressed, to get this working in production, they invested early in evals. I think this was a recurring theme throughout the conference, just how critical evals are to any agent that you deploy. For observability, they did use Langsmith. On the model side, Claude 3.7 Sonnet was their main model, probably 4.0 at this point. They did use other models like Gemini Flash and Gemini Pro for accessory functions. Notably, they do not allow users to pick their own models. And the reason is the number of evals they would need to run would multiply by n, where n is the number of models they would want to serve. So to not to have that evals overhead, they're just not allowing users to choose models. And he did also make a comment that Frontier Labs are moving at an accelerated pace now. They used to be going at a 6-month release cycle 2 years ago, but now it's moving at a 2 to 3 month release cycle. And it kind of seemed like they no longer are spending as much time fine tuning their own models because of this. The next talk I'll highlight is by Russell Kaplan. He's the president at Cognition. This was a really good talk. I learned a lot, so I encourage you to watch it if you have time. But he kind of went into detail of how they make Devin, their software engineering agent. I thought this slide was really good. He talked about trends in AI coding. The first stage was GitHub Copilot, where these were just code completion tools in your IDE, showing you like ghost text and light gray. I think developers are largely familiar with this now. Every AI IDE now has this. Besides GitHub Copilot, you have Cursor, you have Windsurf, you have a ton of different players trying to do this code completion. And I think, it's table stakes now. This is stage 1. Stage 2 was putting an agent in the IDE that you could chat with, where he calls this single player task completion. I think most IDEs like VS Code, Cursor, Windsurf, they all have this too, where you can chat with the agent on a sidebar. It can complete tasks for you. It can not only generate code, but it can generate code and make edits across multiple files. It can, search across files. It can run commands. It can run unit tests in your terminal as well. So it is very much so like a full-fledged agent. And level 3 is now AI agents that are running in the cloud. And this is definitely a shift where, on the left-hand side, you have agents that run locally. So you have this one-to-one relationship with an agent and your local IDE. Once you have AI software agents that are running in the cloud, this does change the game a bit where you can now asynchronously and in parallel run tens or hundreds of these virtual software engineers that can do different tasks. And so the amount of work that one person that can capably manage these just grows quite a bit. Then he went through part one of building Devin. He stressed the importance of building context, where an AI software engineer has to understand existing code. And they are building Devin to work with existing code bases. I think that's one difference between Devin and Replit. I think Replit is more for building net new applications, whereas Devin, they're trying to, get into the enterprise market where large companies already have these massively large code bases. He made a point that the effective reasoning context window of models is much lower than the advertised context window. So that's something to be aware of. You don't want to necessarily fill the context window just because you can. And then he talked about DeepWiki. DeepWiki is a fantastic resource. If you haven't seen it, it's they've basically published these wiki pages that on any publicly available GitHub repo. I think they started with the top tens of thousands of these repos. For example, this is LangGraph's DeepWiki. What's really cool is, this is really good documentation. In some cases I've seen people say that this is better documentation than the repo's documentation itself. And he just went through in detail how they generate this. So this is the algorithm that they go through to generate this, where he talks about how first the algorithm identifies concepts, where for a given repo, you want to discover key systems and services and the names of those services and systems. And notably, he scans through, or this agent scans through code comments, readmes, and commit messages. So, it's important that, for example, you use commit messages here because key information could be held in commit messages. And then concept to code connection. The agent discovers connections between code files and their concepts. And then the agent discovers relationships between code, the actual files, and the actual classes in the code. And then once you have all that information, you can go through each concept and use the agent to research and generate wiki pages about it, and then provide the above artifacts as context for this generation process. Or next, he talked about Devin's search, where on a given deep wiki page, you can actually chat and ask follow-up questions. And so, yeah, this is really cool too. He demoed this question, okay, how can I enforce structured output in LangChain? And because of the rich context that the previous deep wiki algorithm generated, it's able to really do a good job answering questions about a given repo. So, I find that DeepWiki is a great resource when you're working with a new project, just to understand it better. Part two, he talked about Kevin, which is a project they worked on. It's a fine-tuned model that they use to demonstrate that you can actually get pretty far in a narrow domain with not a lot of data to beat, the state-of-the-art language models. So the problem there was to go from high-level PyTorch code like this, end layer norm shape, or NN layer norm module in PyTorch. Under the hood, there are these highly optimized CUDA kernels. I'm not an expert on this by any means, but I think there's a lot of work around writing CUDA kernels and to just do these accelerated operations on NVIDIA GPUs like better and better. And so it's a very active research domain. And he talked about this multi-turn optimization training process they went through. The approach was multi-turn training that involved multi-turn rewards. And so just to describe it a little bit, in turn one, you have an initial prompt. You pass in one of the generated kernels, pass in the chain of thought that led to it, and this would lead to some reward, here 1.5. In turn two, you would pass in all of the previous information, the kernel one that was generated from previous turn one, the evaluation results from turn one, and then you can go through a second round of chain of thought and kernel generation to generate a reward score. What was interesting was he talked about this idea of gamma discounted rewards, where just because a given turn did not generate a kernel that, say, was successful, if it eventually led to a kernel, say, in turn 3 or turn 4, you would apply some reward using like a gamma function to discount it at the earlier turns, because that reasoning trace or that series of turns led to a good solution. And so this apparently led to better final results in their optimizations. And so some of the takeaways from that, custom post-training can outperform frontier models on narrow domains. And the data set they're using was called Kernel Bench. It's the training set for their model, Kevin 32B. It only had 180 tasks. And so it's really small data, but they were limited by compute more than anything. The third point, automatic verification allows you to scale. And a fascinating takeaway I thought was he mentioned how each real-world code base is its own narrow domain. So I think where he's going with this is, I think they want to train code base specific models that do better than, say, the latest frontier model like GPT 4.1 or Claude 4 on that particular code base, because it's been fine-tuned on that narrow domain. So I imagine that's what they're working on. One of the next talks was Harrison Chase interviewing Andrew Ng. That was also a great discussion. I'd recommend a listen. He talked about how, a process of moving human workflows to AI workflows and just breaking that down. You can first look at what people are doing. You can break it down into tasks, and then each of these tasks you can ask, okay, can these be converted to AI workflows? His second point was, as LLMs have continued to progress, we've had to go back and evaluate best practices. So, RAG best practices a year and a half ago have been outdated. One example now is model context windows are pretty large, and so you can often get away without even doing RAG. You can just throw documents into your context and just ignore the RAG step completely. He had this line here, and as you get more different colored and shaped Lego bricks, you can very quickly assemble them into really cool things. So I think he was making the analogy that, okay, you have LLMs, you have agent frameworks like LangGraph or Google's ADK, you have evals, you have MCPs, and these are like Lego bricks. I didn't think the analogy was exactly correct, because one key feature of Lego bricks is they're composable, right? Every Lego brick ever made can be used with any other Lego brick. So, for example, the Legos that I had as a kid, my kids can still play with them, and they work with new Legos that I buy them. But I think AI tooling is not exactly like this. Maybe I'll do a different, talk or presentation about this, but AI tooling has different interfaces. But I have seen some common interfaces surface, right? LangChain themselves, you can think of LangChain as a common Python and TypeScript interface to foundation model APIs. Embeddings, they also have common interfaces to access documents and vector stores. I've benefited tremendously from um, this type of functionality in LangChain specifically. There are these LLM proxy services, like Light LLM is an example. They provide a standard OpenAI chat completions endpoint to different model interfaces or different model providers. So you can use the same schema to call OpenAI, to call Google Gemini, to call Anthropic. And that's also very useful because a lot of other tooling has become standard on this OpenAI chat completions request body. MCP is another common interface that has emerged. This at the agent to tool level, where you don't need to write, say, a Python tool or a tool in, say, Python code that can be used in a LangChain or LangGraph agent, but you can write it once using the MCP protocol, and then any MCP client can then use that tool, which MCP has grown tremendously in the last few months. And agents themselves, I've seen two main protocols emerge. LangChain has this agent protocol that hasn't gotten a lot of traction yet. That was earlier, I think sometime last year it was released. And then Google announced this A2A protocol maybe a month or two ago at their conference. And I think neither of these have gotten a lot of traction. I think A2A is a little bit more popular right now, but it would be interesting if the industry adopts a standard for the agent level. Assaf Elovic, the head of AI at Monday, gave a great talk. I recommend it, but I think Mondays they've done I can tell they've done a lot of product thinking for how to integrate AI into their product. So just going through it. In their product, they allow users to choose the autonomy level of given agents. So say I'm chatting with this campaign manager, I can pick the level of autonomy. The default is here assisted. It can take small actions, but it needs your approval to publish. Versus autonomous, it has the ability to just execute tasks, but it'll keep you informed. And so, yeah, I love this feature. It gives the user more control over what the AI is doing. The second point was the entry point. So Monday had an existing product already. I haven't used it before, but I think you can delegate tasks to people, and users are already familiar with this UI. And so if you can delegate tasks to people, one way to lessen the burden on users adopting AI is to allow users to delegate work to these digital workers. So you can see here this campaign manager, it's under this digital workers menu. And so I think this is a really good way to slowly move toward AI features in a product. The third point was giving people preview access or allowing users to preview what the AI will do. So here, you're asking the AI to add 3 post ideas for this month. The AI, users did not want the AI to just do this on the actual board that they're working on. So here, Monday is giving the user previews of what this will look like. And the user has a chance to review it before it actually goes to quote unquote prod. I thought this was a great feature. Another feature he talked about was also the ability to undo any actions the agent took. I think that was also a really good idea. And then also, yeah, explainability. Anytime an AI generates something, you can have descriptions on more details to build to build confidence in this feature. He talked about some of the reasons why they adopted LangGraph, and yeah, I generally agree with these points. He talked about an architecture just going to skip this for now. And then I think this was a helpful diagram. The digital worker is a multi-agent system where you have a chat-based interface to it. They're using the supervisor architecture where any message goes first to the supervisor agent, and the supervisor agent decides what to do next. It can delegate work to sub-agents. So in this case, you have a data retrieval agent and a board actions agent that each themselves have tools. For example, the data retrieval agent has access to the board data, can use our web search tool. The board actions data agent can create items and just alter the board. And the supervisor agent also has access to an undo tool, which I talked about earlier, and also a math tool. Some of the key takeaways he mentioned was designing for the 99% of the requests you won't know about, where, thought this was a good point. You need to think about what happens if something fails, like what does the agent do? And design for that first, because I've seen this too, where a lot of the queries that come in, they're not anything seen that we saw during development. Second point, build your eval pipeline before your model. Evaluation is your real IP. And I think I'm growing in just seeing how important evals are. Like evals are how you know and build confidence that your agent is working. It gives you the ability to quickly iterate on your agent, like by adding new tools, modifying the prompts, maybe switching model versions. If you don't have a good offline evals pipeline, you're not going to be able to do this well or do this quickly. You'll probably be relying on manual queries sent into your agent, and that just doesn't scale. And then the third point, deploying humans at key decision points, human in the loop during development, and also when the product is deployed is also important to think about. And just his last point, the future of work, he talked a lot about this example of this task of building a quarterly business performance report for a board meeting. You can imagine this is something that Monday and every company has to do. And one day he was saying you can imagine a set of specialized agents being able to do this, as long as that specialized set of agents can solve an infinite variety of problems. And right now, humans do this. Humans can solve an infinite variety of business problems because, we have just the ability to reason over different tasks, to come up with plans, and create new workflows that don't exist. And you can imagine a world where agents will be able to do that themselves, where they do not have to use pre-existing workflows, but they can create dynamic workflows and maybe publish those in a place that are reused by agents, other agents, or that agent in a future time period. I think reasoning models like O3 on ChatGPT kind of do this today. All right, just wanted to go to the next talk. So this is David Tag from LinkedIn. He talked about how they built a generative AI platform for their developers, and just how they standardized it on Python, even though Python was not used in their production services. They standardized on LangChain and LangGraph, and a bunch of 20 teams are using this, and 30 services have been created. So I found it fascinating that they decided to just use Python. Some of the reasons was they tried to use Java to build Gen AI, but it was a painful process. I think because the AI industry generally uses Python, more TypeScript as well. But if you're not in those languages, you kind of have to wait for the state of the art to move into those languages. Like, for example, foundation model providers, I think they all provide a Python SDK, but not all of them provide a Java SDK. MCP is a good example too. I think Python was the first SDK, and now you're seeing more like Java and Kotlin SDKs come out. Yeah, so they decided to standardize on Python. At a high level, their stack is Python, gRPC, and LangChain and LangGraph. What's kind of cool from this slide was they adopted LangChain's logical interfaces. Now, for example, if you've never used LangChain, they have a base chat model that you can use to call OpenAI models using OpenAI chat model. You can call Vertex's models using the Vertex AI chat model, but the schema doesn't change at all. So, as long as you're in the Python or TypeScript ecosystem, because LangChain supports those, you can very easily swap models. And this applies to memory too, embedding models, vector storage, as well as documents, which is not on the slide. And so they're creating these thin wrappers, right? This LinkedIn Azure chat, it inherits from base chat model. Now, by using the LinkedIn LangChain wrapper library, developers that are in LinkedIn can use this LinkedIn Azure chat, which is kind of cool. So yeah, this is just an example of all of those tools pieced together using and building a LangGraph agent. So this has their skill registry on line 3. They have the GPT chat custom LLM inference node here. They have this memory saver that is also custom to them. But everything else is native LangGraph. And so this goes back to the Lego composable thing I was talking about earlier, where they decided to stay in the LangChain ecosystem. And by writing their wrappers in a LangChain and LangGraph compatible way, they can continue to benefit from the open source development around LangChain and LangGraph, which is really great. David talked about their skill execution system, basically tool calling. They created something very similar to MCP before MCP was around. So how it works is the agent has access to the skill registry on line 3 for a given request, like search for a mid-level engineer job. This is going to be sent to the skill registry. It's going to do probably some embedding lookup on the most appropriate skill. In this case, it was candidate search. And then you generate the input parameters, doing the function calling structured output, typical process, and the actual skill is called. So this is similar to MCP, although MCP natively doesn't do, I think, the embedding lookup, although I think there are some tools on top of MCP that are trying to do that. Some of the learnings he summarized were, in order to reduce developer friction, they decided to build this platform where they automate boilerplate. They standardize like patterns by using LangChain and LangGraph, and this made it a lot easier to democratize access, especially for say Java developers moving to Python. They made it relatively more pain-free to do that code change. And he also stressed that at the end of the day, it's still production software, where just because you're building a Gen AI application, you still have to think about the usual things like availability, reliability, and scale. However, with Gen AI, you do need additional things like, for example, robust evals. You need a strong offline evaluation pipeline. You also need some online evaluation to check your production traces too. And so this was also a good reminder. And I think taking a step back, I think from the talk, or from the conference, many companies and teams talked about their agents. And if you dig underneath the hood, a lot of them are actually adopting multi-agent systems. So I think I became a lot more bullish on multi-agent architectures. JP Morgan, they talked about a financial research multi-agent system. Harvey's AI lawyer is a multi-agent system. Monday's digital workers, I talked about already. Cisco's sales organization, um, internal sales organization, they have a multi-agent system on LangGraph. Uber, they've built internal developer-facing agents that are multi-agent systems. And then LinkedIn and this company called 11x are also building multi-agent systems. JP Morgan's agent was called Ask David. It has the supervisor and sub-agent system that I'll go through it in a little bit of detail. I think it has a Streamlit front end based on this icon on the left-hand side, but every query goes back to the supervisor agent. The supervisor agent can call memory and delegate tasks to sub-agents like the structured data agent. The structured data agent can generate SQL queries or GraphQL queries. The unstructured data agent, I think, is just a RAG agent that can do RAG lookups. And then they have a third sub-agent called the analytics agent, where it's a React-style agent that has tools that wrap some of JP Morgan's existing financial APIs that I think calculate things like risk or exposure, typical things in a fund manager. And then all of these agent outputs are passed back to the supervisor agent that could do reflection, and then it'll generate an answer for the user. Cisco, it talked in detail on an interesting agent they built internally to enable their sales organization to make it more productive. So this is like the high-level architecture of it. It's similar to the previous agent where you have a supervisor agent and then you have these sub-agents that do very specific things. I think this pattern of enabling your internal sales organization with information and report generation or research, could be deep research, is something that every company that has a sales organization can build something similar to what Cisco has done. One thing that I'll highlight here is they were leveraging Snowflake's Cortex semantic model, where I hadn't heard of this feature from Snowflake before, but rather than giving the LLM direct access to generate SQL queries, you first give it access to the semantic model, where in that semantic model, you have definitions of data and metrics. For example, okay, what query do you have to write to compute something like AAR? You don't want the LLM to just hallucinate or create its own definition of AAR. So I think this is a good pattern to follow to first layer in the semantic model that the LLM has access to. Just some overall takeaways from the conference. I think evals are one of the most important pieces of an AI system, arguably the most important piece, where you could swap in different models from different providers. You could sub in different sub-agents or different agent architectures, even agent frameworks. But at the end of the day, you need some offline evaluation pipeline that demonstrates that your system is working. So yeah, if you haven't invested in evals, I would strongly encourage you to do that. And yeah, I think also do not be afraid of experimenting with multi-agent systems. I think a lot of them are being deployed to production today. One point was the abilities of each sub-agent shouldn't overlap, similar to how if you have a React style agent, you don't want the tools you attach to that agent to have similar descriptions and similar functions. The same thing applies to sub-agents in the multi-agents world. And then, systematically thinking through the highest value internal workflows that can be automated and improved with AI. I think there's probably many, many internal workflows that businesses can systematically work through to just improve or redo with an AI workflow. And yeah, on my list of things to try out is this open agent platform to enable non-developers. Also this agent chat UI that I haven't had a chance to play around with, but it makes like a chat GPT-like interface on top of any LangGraph agent, and also playing around a little bit with the agent inbox, human in the loop a little bit more for some internal use cases. All right, that's all I have. Thanks a lot for listening.